This is chapter 4. We're starting here, workplace 30. Chapter 4 is about probability and odds. Okay, so you guys have heard those words before, and what's the probability of something happening? It's kind of like, what are the chances that this will happen? The chances are good. The probability is high, right? What's the probability that you're going to come to school tomorrow? Okay, pretty high. Based on your record, you've come quite a bit, thankfully. Okay. I could ask the person that's not here that what the probability, maybe they would be a little lower, I don't know. But what's the probability that you're going to take your next breath? Very, very high. What's the probability that you're going to win the lottery? No, take your next breath, not death, breath. Well, which would mean if you don't take your next breath, you're going to die, right? But what's the probability that you'll take your next breath? Super high. Almost 1. Almost 100% or almost 1.00. Now, the probability is low for things that are not likely to happen. For example, what's the probability you're going to win the lottery? 1 in 2?
Yeah.
No.
Either you do or you don't. That is very true.
Oh, either you do or you don't. Okay. Well, we could critique that statement. Yes. Is the probability that you win the lottery 1 out of 2? Yeah. Because there are 2 choices. Now, what have we just worked with? We've just worked with the weighted what? Weighted what? The weighted. We just got finished talking about. Go ahead. The weighted mean. Now, I'm glad you brought that up because that's a chance for us to review the weighted mean from chapter 3. So if winning has the same weight as not winning, then the probability would be 1 out of 2 or 50%. But we know that winning is not the same weight as losing or not winning, right? So winning is one ticket or one number out of millions of chances that you would not get the winning number, right? So it's not 1 out of 2. That's funny, and it's actually very profound that you said that. I'm really glad you said that, because people could say, yeah, there's only 2 choices, so it's 1 out of 2. It's one of these 2. Well, now that we understand weighted mean, we know that there are many, 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 many more chances to not win, right? Versus 1 chance to win. So I'm glad you brought that up. Okay, very profound. Okay, experimental probability is 4.1. Now, one of the things we need to learn or to remember how to do is to simplify fractions. So we're going to start really, really simple, pardon the pun, but we're going to start simply, and we're going to simplify fractions. So some of you may have calculators that you think, oh, I'm just going to plug this in my calculator and it'll do it for me. Well, it might, and let's see if my calculator does that. 39, okay, so if you do 39, and this line right here is like divided by, right? That means divided by. Divided by 117. Well, I get a decimal number. Now, you may know the fraction that this decimal number is related to. Does anyone know what 0.3 repeating is as a decimal? No, not with your calculator. Does anyone know offhand? 1 over what? It is 1 over 3. I don't know if you got that. Did you do that on your calculator, or do you remember that? Okay, 1/3, yeah, is 0.3 repeating, 1/3. Now, can your calculator reduce a fraction? Can it simplify a fraction? I don't know, maybe you guys could try that. Now, I'm going to say this. I think in mine, you see how this a little arrow to decimal, arrow to fraction? I think if I have a decimal and I want to change it to a fraction, this is the function that your calculator can help you with. And look at that, it's 1/3. Now, so what this means is there's a way to get from 39 over 117, or 39 117ths, to 1 over 3. There's a way to get there. So we have to understand how to do that. And we have to be able to do that manually, not just asking the calculator to solve all of the world's problems, right? Because it can't. It can maybe solve this problem, but that's not all the world's problems. Okay. So what we want to do, and does anyone remember how we used to do this in like when you were younger in other math classes? You want to give it a shot?
Well, we want to find what is divisible by the denominator and whatever.
Thank you. You want to find a number. That's exactly right. That's divisible by both the numerator and the denominator. That's the number on top and the number on bottom. So what number can I divide 39 by and 117 by and get like not a decimal answer, right? Like get an integer number, a whole number. So can I divide this by 2?
You can divide it by 39.
Okay, well let's check this. What if I divide this by 2? Is that a way to reduce this? Well, oopsie. What did I hit? I hit something I didn't mean to hit. Sorry, Movie Maker. I don't want Movie Maker. No, please don't restore. Just end. Oh my goodness. Cancel. What is this? Oh, some video that I was working on. Okay. Let's try this again. Let's hit the right button. Okay. So what's 39 divided by 2? Well, oh goodness. That's not an even number. I can't evenly divide that by 2. So guess what? That is not the way you reduce. So let's erase that. Now, so aptly noted that I could actually divide both the top and the bottom by 39. Now you might not have seen that right away, and you might start with smaller numbers, which is fine. But if we do that, so obviously 39 divided by 39 is going to give us 1. That's a whole number. 117 divided by 39 is going to give us, oh, look at that's another whole number. So this is a way that we can reduce this fraction. And of course the top becomes 1 and the bottom becomes 3. All right, we're getting somewhere. Now, what about this one? You just want to think of a number, any number, that both of these can divide by evenly. And then you check that answer again and see if there's another number that you can divide, or see if you can do it again. So let's say I'm going to divide both these by 2, okay? Because I know they're even numbers, I can divide them by 2. I get 32 divided by 2 is 16, 48 divided by 2 is 24. Now you'd say, oh, there we go, I'm done. Well, you're actually not done, because you want to do this process again. Can you divide them by another number, or 2 again? You can divide by 2 again. What's the largest number that you can divide both of these evenly by? Anybody? What's a factor? What's the largest common factor? So it's the greatest common factor between these two numbers. 4?
Yeah.
Oh, okay, let's try 4 then. Awesome. Now let's see. So 16 divided by 4 is?
Oh, 4.
4, thank you. And what's 24 divided by 4? 6. Okay, so now are we done? We're actually not done. Now 4 was not the largest number that was common. Okay? But yeah, if you get to this point, you say, hey, listen, there's another common factor. I can divide both these by 2 again. Not by 3. 4 doesn't divide evenly by 3, but this becomes 2 over 3. That's your final answer. If you checked on your calculator, and yes, you can use your calculator, but you guys have to know how to do this without just getting your calculator to do it. So 32 divided by 48, and if you have some kind of fraction button, and you have to figure that out if you do. I don't know if you do, but what's the fraction? Let's try it. Oh yeah, there we go. So if you type in a fraction and you say, hey, I want you to reduce this for me, it'll show you 2/3. Now that's my calculator. Your calculator might be different. And like I say, you can figure that out, great, but you have to know how to do it by hand. So, all right. So if you look in your workbook as well, here's the solutions that they provide for those. And of course, yeah, what they do is they simply divide by a number that will give us, that's divisible by each the top and the bottom. All right. So let's do some work here, okay? Without going straight to the answer just via the calculator, what number, and you'll have to show this work, okay, for your problems and your tests and stuff, so I can see that you actually understand this. So what can I divide both of these by, do you think? Is there a number? First of all, 2. 2 is always a good one to start with. It might not be the largest, but this one is odd. It's an odd number, so you can't divide that evenly by 2, right? So what about 3 or 4 or 5 or, I don't know. What do you think? Is there one that pops out to you? If they're big numbers, you know what? You just might have to just get on your calculator and say, okay, let's try this out. I know you know that 45 has factors of, that's 5 times 9, right? So do 5 or 9, are those factors of 72? 9. So let's do this. Let's try that. That's a pretty big number. I like that. So let's see if this works. 45 divided by 9 is 5. And 72 divided by 9 is 8. Ooh, that looks pretty good. 5 is a prime number. That means it doesn't have any factors other than itself and 1. So this looks like it might be lowest or simplest form. Is this simplest form for the fraction. Is there any other number other than 1 that you can divide both of these by evenly? No, there isn't. So this looks like that should be your answer. Okay. Now, when the numbers get bigger, it gets a little tougher. And you know what? You just may have to get on your calculator and just try. Now, I'm noticing this right away for C. Both of these end with 75. So you know what's a factor of 75? 75 is, you could try 75. If that works, great. If that doesn't work, you could try 25. So let's try 75. What do you get? What's 675 divided by 75? Is that
9.
Okay, that's 9. Okay, so let's write 9 down there. And does 1575, does that divide evenly by 75?
21.
Oh, 21. Awesome. Okay, 21. Now, this is great, but again, you have to think to yourself, is this the answer? Or can I divide 9 by something and 21 by the same thing? You can divide them by 3. Very good. So 9 divided by 3 is 3, and 21 divided by 3 is 7. Those are both prime numbers. They have no other factors that are common because they're prime, so we're good.
What does prime mean?
Oh, prime. Okay, let me explain prime. So if a number is, there's two types of numbers, prime and composite. So prime means that the only factors in the list of numbers that multiply together to get that number is only 1 and itself. So 2. Okay, the factors are 2 and 1. That's the only combination. What about 3? Factors are only 3 and 1. What about 4? 1 and 4, but also 2 and 2. So if they have a list of sets of factors, like more than one set of factors, it's a composite number. A prime number only has one set of factors. That is 1 and itself. So 5 would be prime as well. So if that's 5 and 1, those are the only two numbers that multiply to 5, right? What's one more prime number? 7, yeah. Awesome. Yeah, okay. All right, so that's the examples for that one. Let's see, what's next here? Okay. Let's keep going with this lesson and talk about just reviewing fractions and all that sort of stuff here. So fractions, decimals, percentages. Okay. So this should be pretty easy. Whoops. This should be pretty easy for you guys as well because you guys are pretty bright and we just got done doing this. So, all right. So this chart, you see, this fraction can be written as a decimal, and a decimal can be written as a percentage. Okay. So how do I find the decimal form of a fraction? What do I actually have to do? Hint: it involves using your calculator. What do you think? Yeah, you divide. That line here is the same as a dividing line. So 1 divided by 5 is 0.2. Okay? So that's the decimal. Now what's the percentage? Do you remember how to convert decimals to percentage? You multiply by 100. So what's this? What's the percentage here? 20. Isn't that easy?
No.
Yes, the answer is yes to that. It is easy. Okay. Sorry, wrong answer. Do you understand? Oh, you don't understand? Sorry, that's the wrong answer. Okay, just joking. So what about the second row? If we start with a decimal, well, percentage, that's easy to get. You move that decimal place over 2 times or multiply by 100. How do I get the fraction? How do you write a decimal as a fraction? Okay, so 70%, that one we know is 70 over 100, which is equal to 7 over 10. You can divide both sides by top and bottom by 10. Can this be reduced any further? Nope. 7 is prime, so can't divide it by anything other than 1 in itself. Now, if 10 was a multiple of 7, you could divide both by 7, which that might happen later, but okay? Well, I'm just saying that because you run into a prime number, it doesn't mean that it can't be simplified. For example, what about this? Oh, 7's prime. I can't simplify it.
Well, yeah, but 7 divided by 7.
That's what I just said. So you could divide both sides by 7 sometimes.
It would be
1 over 11, right?
Okay.
So that's just as an example. That's what I'm saying. I think you just missed that part.
Yeah, but just so that we divide 7 divided by 10.
Nope. Okay. What about the third row here, guys? 12% as a decimal is
0.12.
very good.
Would it be 12
Okay, well, it's 12. Okay, what you could do is you could say, I know that this is 12 over 100 because that's what percent means. Now you go ahead and can you reduce that? Well, you could divide both sides by 2, or top and bottom by 2, so that's 6 over 50. Am I done there? Maybe not. I can divide both sides by 2 again. That's 3 over 25.
You're divided by 3.
Can you, okay, does 25 divide evenly by 3 though? You want to check that? Yeah, so that doesn't divide evenly. So it looks like 3 over 25 might be your simplest form there. You see how I did that?
Yep.
That makes sense? Okay, everybody getting that? And I have a confirmation there. You understand? Yeah? Okay. All right. So let's see if we did that right. Oh, here's the answers. Looks like we did that right. Okay, so this is the build your skills question. It's just another chart like that. Let's do the first row, and then the rest will be yours. So the first row here, 0.89 again as a percentage. What do? We multiply. You said by 100. That means moving the decimal place to the right 2 times. So that's going to be 89%. Awesome. As a fraction, you can always start with 89 over 100, right? We know that. And even from this decimal, see this first space is the tenths space. The second space is the 100ths. So if you have 89, and that's where this number ends, that's 89 over 100. So can I reduce this any? Well, I can't divide by 2. What else for 100? I can divide 100 by 4. I can divide 100 by 5, by 10. So what does 89 divide by? You might have to check. Why don't you go ahead and just check a few. 89 divided by, try 3, 4, 5, 6, 7, 10, 8, whatever. See what you get. Okay, so after checking a bunch of numbers like 89 divided by 4, divided by 5, 6, 7, 8, 9, 10, 11, 12, 13, you didn't find anything. And the fact is that is actually simplest form. So 89 appears to be prime. 89 appears to be a prime number, doesn't it? It doesn't divide by anything, let alone 100, okay? So, all right, so that's one row there, and those are your 2 answers. So let's take a look at one more little section before I set you off on finishing this. So working with experimental probability. All right, so if we're talking about experimental probability, basically that is a probability that is determined by experience, determined by some data that we've collected experimentally. So for example, what are the chances that you are going to come to school tomorrow? Well, if somebody asked me that, I would say, okay, well, I mean, obviously I don't know what is going to happen in his life in the next 12 hours. But what I can do is I could say the chances are pretty high because, why would I say that? Because what?
His mom's a teacher.
Okay, his mom's a teacher here. Okay. But the chances are pretty high because what? What's the obvious answer?
He's sleeping over at school.
No, because he's here most days. That is because of all the days we've had school, Curtis has been here almost every day. Now, you've missed a few things here and there, right? It's like everybody. But the probability is high based on the data that I've collected on Curtis. So that's experimental probability. It says the ratio of the number of occurrences of a particular event during an experiment or trial to the total number of trials conducted. That's just fancy schmancy for basically saying what are the number of positive results to the question divided by all the possible results. Okay, so based on experience, that's experimental probability. So here it is right here. You might want to highlight this in your notes. The number of occurrences of event A divided by the total number of possible outcomes. So that's what the probability of A. That's how it's calculated, a simple division. Now notice this, that the probability is going to be a decimal, right? It's not automatically going to be a percent because we're just talking about number of times this happened out of the total number of times. So let's say that the probability that you're going to come to school based on experiment or based on previous data that we've collected, let's say that if we've had, I don't know, what if we had 40 classes, you've come to school 38 times out of 40, let's say. Do you know how many times you've missed? How many classes have you missed? 3, okay. So let's say 37 divided by 40. Okay? So that means this is the probability that you come to class in total, based on experiment. So I would be safe to say there's a 93% chance he's going to be here tomorrow, based on what I know. Does that make sense? Experimental probability. So really when we're talking about weather and stuff, the chance of precipitation, or the percent POP, percent of precipitation. So that's like, what are the chances it's going to rain or snow? Well, when the conditions have been like this before, it's rained or it's snowed or whatever it is, it's rained 90% of the time. So there's a 90% chance it's going to rain. It's based on experimental probability. Okay. So let's just cut to the chase here. Let's get to actual question and do one of those so that you can actually see what's going on. A grocery store sells 3 brands of toothpaste. Okay, so this is on page 148. Okay, and the question says this. Last month, the store sold 75 tubes of brand A, 23 tubes of brand B, and 57 tubes of brand C. What's the probability of a customer buying a tube of brand A? Express your answer as a simplified fraction. Okay, so the grocery store only sells 3 brands of toothpaste. So I guess the total number of toothpaste tubes that have been sold would come from where? How would we figure that out? Add them all together. Exactly. So the total, so the probability of, what does it say? Brand A. Probability of A comes from the number of brand A that was sold, 75 tubes of brand A, divided by the total number of tubes that were available. So that is 75 plus 23 plus 57. And there we go. So on your calculator, you can do all that at once. You have to be careful though. You have to use your brackets, okay? Oops, on, clear. So 75 divided by, use your brackets, put a bracket there and then do all the addition. 75 plus 23 plus 57. End the bracket. So you're telling the calculator to do 75 divided by the total here. And what do you get? 0.48387. 0.48. Okay. So what's the probability of customer buying brand A? Well, the probability is 0.48. Thank you. So it's a little less than half. Right? And if I was to show this as a percent, you would simply multiply by 100, and you would say it's 48% chance. Okay? But you don't need to write it as a percent. Probability is, it's okay to write that as a decimal. Now, can probability be 0? Can probability be 0? If there is a 0 chance of something happening, probability can be 0. If they sold 0 tubes of probability A, of toothpaste A, you would say probability is experimentally 0 out of the total. What about, can probability be 100 or 1.00? Can it be that? It can. If something is absolute certain to happen, that's the probability. Can the probability be like 1.3? Experimental probability, that would be like saying something happened 13 times out of a possible 10 times. Right? That doesn't happen. You're all on? Okay? Good? You good? Okay? So yeah, so probability is going to range from 0 to 1. The percent is going to go from 0% to 100%. That make sense? Yeah? Okay. All right, so I will stop the teaching there, and I'm going to let you work on your Build Your Skills questions. So please go to the end of question number 5, and that ends on this page 150. Please work on that for the rest of the class, and this is where we will pick it up for part 2. After your test. I guess you guys got a test tomorrow. So yeah, we'll pick that up after the test.